Okay, so the first part says find the product. What does product mean?
Answer. Or like,
Multiply it.
yeah.
Yes? These are factors you need to multiply. So multiply number 1. Hopefully you do it correctly. There's no way you're done multiplying that yet already.
Then I did it wrong.
Foil it.
Foil? What is that?
Distribute to everything. Okay, you should have gotten 16p squared plus 4p minus 2.
How'd you get squared? How'd you get 4p?
Well, 8p minus 4p is 4p.
How'd you get squared?
Because p times p is squared. So 4 times 4 is 16p squared plus 8p minus 4p minus 2. You should be able to do that without making mistakes. That is a skill that you've been doing for a long time.
You just didn't give me that.
Okay, so these are factors. This is a polynomial. We are going to go from polynomial to factors. The first part of it is because you need to know, like I did this 4p in my head because I did this multiplication and this multiplication gives you your middle number, correct? So this is 8 minus 4 is 4. Every single time, if they're common variables, the outside combined with the inside will give you your middle term. That gives you b. Okay? So your first part of your assignment is to multiply those out. Bless you. The second part of your assignment is as follows. Number 9, it just says number 9 is factoring rules because it won't let me put it in any other way. So, these are factoring rules. I have ax squared plus bx plus c. We're going to factor this position and this position are the factors of a. A's are the factors of the leading coefficient. C's are the factors of the constant. And A times C plus C times A gives you B every single time. Never changes. So our factoring patterns. I take A times C, yes? Every time. A times C, I'm going to work my way back through my pluses and minuses. If I have a positive A times C, it is the factors that add to get B, and this tells you you're both positive. So it would be plus plus. This is only the plus plus. Okay, then the next one, we're going to add to get B, and they're both going to be negative. This is just reviewing what you did last year at the end of the year with me and what you did in Algebra 1. Okay, then we have a minus on the C. So they're not going to add, they're going to subtract to get B, and the larger factor is going to be a positive. So plus minus. It could be minus plus. It doesn't matter, but the plus goes on which one? The biggest factor, the largest factor. If I have a negative C, then they're going to subtract or have a difference of B, and the larger factor is going to be negative. Last year when I did these with you, I did the X for a while, and then I quit. When we have a prime, if you look at the top of your sheet says prime leading coefficients. Yes? So prime means one in itself are the only factors, correct? So when you have prime leading coefficients, you should not need to do the complete whole x and factoring by grouping. Remember doing that? You do the x and factoring by grouping. Because the factors of A go here and the factors of C go here. Well, if you only have one choice of factors of A, should you have to go through this whole process? No. Okay, so we're going to start. We have 5x squared plus 25x minus 30. What is the first thing I should do?
Add like terms.
Nope, there's no like terms. We are factoring.
Make parentheses.
Nope. 5, 25, and 30.
Oh.
Multiply 5 and 30.
Nope.
Exponents.
Factor out what?
5.
5.
Yeah.
Why?
Because they're going to say.
They all have 5. I don't have to, but I'm going to eventually have to do it. And wouldn't it be nicer to work with smaller numbers?
Mm-hmm.
Yes? So I'm going to have 5 times what?
Make x squared. Plus 5.
5x. Minus 6.
Minus 6. Okay? So now it's still a 1. It's a 1 here now, yes?
Mm-hmm.
And I still do this x a little bit. I just don't write the x. Drives me nuts.
I remember
I still have to take 1 times 6, yes? So I have 6. So I have the factors of 6 that add or subtract.
to 5.
Well, I'm asking add or subtract. Which one?
Minus.
Okay, they have a difference of 5. And the bigger one is going to be what?
Positive.
Positive. So what are the factors of 6 that have a difference of 5?
6 and 1.
3 and 2 have a difference of 1.
6 and 1.
6 and 1. Okay, so what are the factors of 1?
They're what? Just 1?
Because the factors of A have to be first, yes?
It's just 1.
It's just 1. So I have x and x. Yes?
Yes.
And then the factors of C go in the back. Well, what factors of C had a difference of 5?
6 and
6 and 1. So 6 and 1. Which one's positive? Which one's negative?
the 6 is negative.
It would be.
No, the 6 is
Positive.
6 is positive.
Why is negative?
Why is the 6 positive?
Because the 5 is positive.
Because the 5 is positive. And don't forget to bring down your 5.
That's it?
That's it. It's factored.
Factor is a scary word, but it's easy.
Okay, if as long as you follow the rules, it doesn't change, just the numbers change. I have 2 terms, yes?
Mm-hmm.
Okay. Well, before I do anything, I should factor out what they have in common. 1, what? Nope, they got more than 1.
X.
X. So X, that leaves me with what?
X plus 6.
X plus 6. Is that factored then? Am I done? Yes. Is that okay? 13.
Nothing.
They have nothing in common, but that's a special case right there in front of you.
What's the difference of squares?
It's the difference of squares. How did you know that, Sam?
Because 36 is a perfect square and x squared is a perfect square.
Yeah. 1 is a perfect square. X is squared is a perfect square. 36 is a perfect square. And what's in between them?
A square.
A subtraction. So the difference of squares is a special rule. Does anybody remember how to factor that?
No. A square.
Hmm?
Side?
No. Okay, so what I have here is essentially x squared plus 0x minus 36. Yes?
Mm-hmm.
Okay, so the factors of 36 that have a what?
Negative.
No, sum or difference. Difference of what?
36.
So what factors of 36 have a difference of 0?
6 and 6.
6 and 6. One has to be what? One has to be what?
One has to be negative and one has to be positive.
So if you just remembered the rule, would it be easier? Yes?
Yes.
So what if I gave you 49x to the 4th minus 144. No, I wouldn't give you 144. Because then, no, I would. 144. First of all, do they have anything in common? Nope. Okay. Are they perfect squares?
Yes.
49 is, x to the 4th is, yes. Any even power is a perfect square. So 2 is 1 and 1, 4 is 2 and 2, 6 is
What?
3 and 3. Like to the 6th power would be 3 and 3. Okay. Is 144 a perfect square?
Yes.
Yes. So, what's the square root of 49?
7.
7. So I have 7x
Squared.
squared and 7x squared. What's the square root of 4? 12. So 12 and 12. And one has to be positive and one has to be negative. So if you remember difference of squares, could your life be easier? Yes. That is a special rule that you should use when you can. Because if not, you're having to do the whole thing out. Okay. Do this one on your own. See if you can do it. So you're still multiplying 1 times 40. Just remember that. Just doesn't change it, right? Olive, what'd you get?
I can do it. Like, I haven't finished it yet.
Oh, you're finishing it?
Yes.
Okay. I thought you were done. You put down your pencil.
No, I was thinking of numbers. Do you want it?
Is everybody ready for Olive to holler it out? No? They're not ready yet. Coop, you ready? Austin?
Yeah.
Okay, go for it.
Okay, so I got 1 and then parentheses m minus 5, and different parentheses m plus 8.
Okay. Yes, you're right.
What?
Okay, so when I do it, I know this is 1, so I put M and M to start. Did you guys do that? Did you write M and M? Okay. And then she did minus 5 and
Plus 8.
plus 8.
But you don't have to bring down the 1. Or do you not
No.
have to?
The 1 is on the M squared. You didn't factor it out.
Right. Do you have to bring it down? Okay.
No. Because if there's not a coefficient shown, the coefficient is always 1. Correct?
Yeah.
So you don't have to. To me, I think it clutters it up. Does that make sense? Okay. So we did some nice, easy ones. I want to look at 16. We're not going to do 16, but you're going to tell me the first step you do on 16.
Take it out by 5.
You'd factor out a 5. So you'd have what?
M squared plus 12.
Plus
Plus.
36?
Yeah.
Oh, we were going to do this one. This is a special one, too. Okay.
Is it 36?
Yes. Because 5 goes into 18 3 times with 3 left over.
Oh, yeah. Wait, no.
Yes.
Oh, it's 5. Never mind.
5 goes in
I was
here
thinking
3
it was-
times.
I thought I was
With
thinking
three
of
left over.
3s for a second. I was like, 3 goes into 8.
Okay. So factor that. N squared plus 12n plus 36. And then you got to tell me why it's special. Because it's a special case, too. Bless you. Gracie, do you have the answer or why it's special?
I have the answer.
Okay, what do you got it? Gracie?
5, and then I have inside the parentheses n up plus 6, and then the end of parentheses, and then n up plus 6.
You could just say quantity n plus 6,
Um,
or just n plus 6 times n plus 6, because we know we're doing quantities. Did you guys get that?
Is it special about it? Is that it's the same thing twice?
Right. So technically I should write
5
n plus 6 squared. Now, you guys always try to tell me that n plus 6 squared is n squared plus 36, but it's not. It is n squared plus 12n plus 36. Yes?
What'd you do with the 12?
The factors of 6, 36 that add to 12. 6 and 6. I didn't do anything with the 12. Like, if I multiply this out, I'd have 6n and 6n, which would be what? 12n. Okay? So this is called a perfect square trinomial.
Will we have another one?
I think so. Okay.
Which one?
I don't know. Okay. Perfect square trinomial. Because when we factored it, what did we have? Did we have a perfect square? Yes. Now, this is how you can tell if it is a perfect square. What is the square root of 36? 6. Is 12 double 36?
Yeah.
Yeah. So if I had 49 at C, if I had 49 back here,
Wait, 12 doubled is 24.
no. What's the square root of 36?
6.
Doubled is
Oh.
12.
My
Okay, so what's the square root of 49?
bad. 7.
7. So what would make this a perfect square trinomial then,
14.
if this was 14? You know what I'm saying? So if you look at it and you identify, ooh, 36 is a perfect square. So what if I had 144? What's the square root of 144?
12.
12 doubled is
24.
24. So if I had 144 and 24, would I know, should I be able to see that that's a perfect square trinomial? Yes. Now, what's even better about this, guys, if I put a y out here, don't I have this in vertex form?
Yes.
Because this is my h, yes? And what's my k? 0. So that just moves left 6, doesn't it? And the rate of change, so it goes narrower because it's 5. We will be making perfect square trinomials here next week. We'll be making them with the process called completing the square. So a perfect square trinomial is nice to know because I would bet over half of you, if I ask you to take n plus 6 squared, you would tell me that's n squared plus 36, wouldn't you?
Yes.
Yes. You shouldn't, though, because you should take n plus 6 times n plus 6, and when you FOIL it out, what do you have in the middle? 12. Okay? There is no sum of squares out there without imaginary numbers. So if you recognize the pattern for a perfect square trinomial, then you can just say, what is the square root? Is 36 or 6, and so you can just put n plus 6. Okay, 17. What should I do with 17 first?
Take out a 6.
Take out
For
6.
factor 6. Yeah.
Okay. So n squared plus
9.
9n
Minus 10.
minus 10. I'm not going to do any more because I just wanted to make sure you are going to go back and finish that yourself. Got it? Go to 19. What are you going to take out of 19?
Nothing.
Nothing. You want to take a 3.
Yeah, but it doesn't go to 6.
It doesn't work. What?
So I got a question. So problems like these when you can't. So would you take 3 times 21?
Yeah. Let me finish. Yeah, let me finish. Okay. What is special about 3, though?
Wait, what?
What kind of coefficients are we working with today?
Oh, prime.
It's prime, yes? And remember I told you when I do the factors, right here are the factors of A, yes? So what are the only factors of 3? 3 and 1. So can I go 3A, or not A, it's an N. sorry. 3n and n right now before I did anything else. I can, can't I?
Yes.
Yes. So now, yes, Gracie said, don't we have to take 3 times 21? Yes, you do have to take 3 times 21, which is 63. Yes? So now I need the factors of 63 that do what? Sum or difference. Add to 16, and the bigger one is negative. Okay? So I need factors of 63 that add, actually, not the bigger one. If they add, they're both negative. So could I both put a negative here? Yes?
That's 7 and 9.
Okay?
No. Yes.
8 and 8.
No. 8 and 8 are 64.
7 and 9.
7 and 9, yes? Did I just do the x?
What?
Did I do the x?
Yeah.
Did I do the x?
You did do the X.
I did do the x. But did I have to write all that extra stuff? No. I still did the x to organize myself, didn't I? Okay, so now that we know there's 7 and 9, and I wrote them there for a reason, because they do not go right into here. I need to get 7 and 9 to give me 16, yes? Do you remember how I multiplied to get the middle number? It was this outside combined with the inside, yes? Here's the factors of A. Here is the factors of what? C. So I have a 3 already, yes? And I need to multiply to get either 7 or 9. So can I multiply 3 by anything to get 7?
No.
No. So can I multiply 3 times something to get 9?
3.
3. Is 3 a factor of 21?
Yes.
What's the other factor of 21?
7.
Oh, isn't that convenient? So what goes here? 3. Why do you know 3 goes here? Because you need to get what?
21.
No, you need to get 3 times 3 is 9. And this one is what? 7. We are using our multiplication process as we are dividing, because factoring is dividing. When you do long division, do you multiply at the same time?
Yeah.
Yes. So when you factor, shouldn't you be multiplying at the same time? Yes, you're going back and forth between those two things. Okay, 20. How would I check this? I would just multiply it out, wouldn't I?
Yeah.
Okay, 20. What are you going to do?
I
Take out
took a
3.
3 out, but I know you can take out bigger.
Well, 6 goes into 30 and 12, yes?
Does it go? Doesn't minus 96?
6 goes into, yeah?
It does.
Yes. Okay, guys, is 96 even?
Yeah.
So 2 goes into it, yes? 9 plus 6 is what?
15.
15, so 3 goes into it. So if 2 goes into it and 3 goes into it, what has to go into it?
6.
6.
I was like, I know there's something bigger.
Okay, so 6, what do you get? 5x squared
Plus 2x.
plus 2x. Now remember, use your long short. So you're imagining a 6 under here, yes?
6.
So it goes in here once with 3 and 6. So we're using our number sense and our kind of shortcuts on processes, right? So now, is 5 prime? Yes. So I know 6. And what has to go in the first place of these?
5.
5x and
X.
x. Now, this is going to be a difference, yes? Like on the last one, it was a sum, so I could just put both of them minus, but I can't put both of them minus here because I don't know which one goes where yet, do I? Because if it's a minus, one's going to be positive, one's going to be negative. Okay, so I have to take 16 times 5. I believe in we can do this. So 5 times 6 is 30, so we put a 0. Carry 3. 5 times 1 plus 3. 8. Okay, so I need factors of 80 that have a
10 and 8.
Difference of
difference of 2. 10 and 8. Those are the ones we always forget. Okay, 10 and 8 have a difference of 2, yes? Which one is going to be positive?
10.
10. So I put a plus 10 and a minus 8 just so I remember. Okay?
Wait, we're not doing that yet?
No, we don't. No, because we got to figure out where to put the factors. Because we have to take the factors of 16 now, right? So I need this multiplication and this multiplication to be able to get me 10 and 8. Well, I have a 5. So is 5 times anything going to give me 8? No.
5 times 2.
5 times 2 is going to give me 10. Is 2 a factor of 16?
Yes.
Is the other one 8?
Yep.
So are we good? So clear over here gives me a 2. And I want my 10 to be positive, so the 2 has to be a
Positive.
positive. And then 8,
Has to be negative.
it has to be negative. Do you see how I'm using my multiplication patterns to do this? Do you think this is going to help you multiply quicker? Yes. I know a lot of teachers that do not teach their students to factor this way. They all say, use the X, use the X, use the X. Why should I use an X when I don't need to? Like, why should I write out that big factoring by grouping thing if I don't need to? Right? Okay. So, 21. Does that look good?
What do you want?
That's right.
Okay. On 21, what should you do first?
A negative?
A negative. Do we ever want a negative leading coefficient? No. Too bad nothing else can come out, but that negative definitely has to. I'm going to tell you guys, I'm on my 19th year, 18th year teaching, something like that. I've had one student that could factor with a negative leading coefficient and do it right every time. One. She loved doing it. I'm like, you are weird. I cannot consistently, I know what I need to watch out for, and I consistently do not do it right. Like, I would do it wrong more times than I would do it right. Just factor out the negative. It was a long time ago.
Who was
Nobody you know.
Yeah, that's why she's telling me. Yeah, I'm a Facebook stalker and send her a message and be like, Miss Mick is telling me all about you.
I said she was amazing. Okay, so when I factor out a negative, I factor out a negative on everything, so it gives me the switches of signs, right? Okay, so when I'm done with my answer, I'm going to have a negative at the end. Is 5 prime?
Yes.
Yep. So can I go ahead and just put my negative and then my...
It's 80.
Just wait.
Would you can it?
Stop. Okay, so what goes in the first spots?
5.
5A and
1.
A, 1A. Because it's prime, yes? Okay. And yes, 5 times 16 is 80. We just did it. But this time we're not going to subtract. We're going to what? Add. And they're both going to be what?
Positive.
I had 2 answers. Which one?
Positive.
Positive. Do you see that, Sam?
Yeah, I was still.
You were looking at the original one, right? So this is why I love this method. Guys, I have this 3/4 of the way done. Correct. I got 75% already on that problem. Woo-hoo, right? And I didn't have to do much. Okay, now I need factors of 80 that add to 42.
Wait, 40 and 2.
40 and 2. And hopefully you're drawing your arcs, guys, until you can see them without drawing them. Because that's what we need, those 2 arcs, yes? Okay, so 5 times something,
8.
8 is going to give you what?
40.
But before I even write it in, am I checking is 8 a factor of 16? Yes? Is the other one what? 2? Is that what I need?
Yes.
So 8 goes here, and 2 goes there. Do you see how factoring shouldn't be such an ordeal, should it? It should not be the process that you guys make it. It's just number sense. Where do things go and how do patterns work? Patterns are amazing.
Can we do 15?
Oh,
15's so easy.
There's no number.
Hey.
What do they have in common?
Oh, wait. But then I didn't say that. Then M minus.
Okay, I want you to do 24. Try it by yourself.
Is it 1? It's 1.
Is it 1, Gracie?
Yes, it is.
Hey, Gracie's at 1.
Okay,
Yeah.
shush.
What one?
24. Try 24 on your own. Can I start?
No.
No? Okay.
Wait, start asking for the answer or start?
No,
working?
start me working
Oh,
it.
yeah.
Yeah. Okay.
Go for it.
My pen is dying. I just wanted to give you guys more of a chance. Should not be.
There might be
Focus.
bubbles.
There might be a bubble.
Well, it might just be stained.
Shake it.
No, I think it's fine. Guys aren't done yet? How'd you get 105?
5. What?
You should have taken 5 times 21. How'd you get 105? 5 times 21. What's 5 plus 21?
I'm thinking of numbers.
I got my number.
5 plus 21. What?
Okay.
Oh!
Always start with the two numbers that gave you what you multiplied together, guys. Because 5 times 21 is 105, yes? And your brain is 5 and, okay. Your brain's going through all these weird things. But start with where you got it. What is 5 plus 21?
I already got
Okay,
26.
good. It's 26. Don't be making it hard, okay? Don't be making it hard. I always
I
start.
just multiplied wrong.
Oh, okay.
And divided wrong.
That. Oh, woo. Okay, you did all wrong.
I got
If you multiply wrong, your ship is sunk. Yes, because you're
Yes.
probably not going to find them. But did anybody watch how I did it? I did the 2, or did anybody else do it this way? I wrote the 2 parenthesis parenthesis. I wrote 5p and
Yeah.
plus before I did anything else.
Yeah, that's
Yeah.
what
And it makes you feel like you've accomplished something. Yes,
Yeah.
it does. Little.
I think 21. What?
40 divided by 2.
Oh, that should be 24. Thank you, Sam. I was so excited.
That's what I had.
Okay, then that wouldn't be the answer then, huh?
I was like, this
Gosh dang it.
I know.
Gosh.
120.
is.
I ran across this to let you appreciate it real quick.
I had that.
Oops, sorry.
And I thought I was wrong.
Thanks.
That's how I used to feel when I had to do math problems.
Me too.
Especially story problems.
Yes, I got to read them several
It
times.
was 20 and 6.
20 and 6.
How?
Because 2 times 6 is 12.
Oh.
So then we got here and here. Anybody else doing their arcs?
Oh, 5 times 4.
Yes.
So 4 is 4 factor 24.
Yeah.
Is the other one 6?
6.
Yeah.
Yes. Do you see how I'm checking my work as I go? I don't know where I got 21. Evidently, my brain said 21.
I was like,
I'm surprised it worked. Usually, when you do stuff like that, you can't get it to work. I got it to work.
That worked perfectly too.
Yeah. Okay. Now, if I ever get something, let's say I had 10p plus 6. Does 10p plus 6 have something in common? That's a 2, right? So should I have taken out a bigger number at the beginning? Yes. You
Like-
can't leave common factors, so you'd have to factor out another 2.
Oh, so then it would be 2, 5p. Wait,
So, like, if
what?
you had 2, 10p plus 6,
But it was
and
5
then
as well?
p plus 4, if I had that, okay? P plus 4 is good, but 10p plus 6, does that have a common factor?
2.
2. So I'd have to factor out a 2, so 2 times 2 would be 4, and it'd be 5p plus 3 and p plus 4. You can't leave common factors in there, okay? It means you should have factored out more at the beginning and your problem would have been easier, correct? So, do we want to do one more? You guys think you got it? I think you guys got it.
I did 28, but I don't think I did it right.
Let's do 15.
We'll multiply it out.
God, that was such a dumb statement. Is that it?
Hmm?
Is that it?
What?
If I multiply it out.
If you multiply it out, you should get what you started with. So if you multiply out what you factored, do you get what you started with? Okay, then you're right. Okay, so you don't have that many problems on your own. 2, 4, 6, 8, 10, 11.
Oh.
So get busy. Oh, in the front, you got to multiply on the front.